alcohols and introduction. So let's look first at water. Okay, water is a very common inorganic molecule. What we're going to do is to derive organic molecules from it by replacing the hydrogens with carbon chains, or more complex things here, but basically replace with some organic group, the R group. So I'll replace one of these with an R group. Then I'm left with a hydroxyl group here. And this functional group is the alcohol group. So these compounds are alcohols. For example, I can have methanol, so HC, so I have my OH here with 3 hydrogens here. And this will be methanol. Okay. Now, or I can have ethanol. What we normally call alcohol. But in organic chemistry, anything with an OH group is an alcohol. That's an alcohol functional group. Now, we're going to replace both hydrogens in water with R groups, which can be different groups. So for example, I can put a C2H5 on each end. Which is ethane. Okay, and if I have ethoxy, this would be an ether because we've got an oxygen between the two organic groups. Note that these two groups do not need to be the same. Let's focus now on alcohols, okay, and look at how we can classify them. What we can do is to look at what is bonded to the alcohol. Now, number one is that we've got our OH group will always be bonded to carbon, and then we can put whatever you want on it. So let's see now. The simplest will be methanol. Okay, or if we go a little bit more complicated, I can put another carbon here or more carbons here. Let's say if we put any carbon chain here, but leave the other two here as hydrogens, then we have a primary alcohol. Only one of the 3 positions is occupied by carbon chain. Up to 1. Okay. Now let's look at this. Now, what if I have 2 different carbon chains and only 1 hydrogen left bonded to the central carbon? In this case, we have things such as isopropyl alcohol, so, or 2-propanol, okay. And in this case, we have 2 R groups bonded to the carbon, only 1 hydrogen left, and this is a secondary alcohol. Finally, what if I replace all 3 of these? Well, I have different R groups around all of the around this carbon. There are no hydrogens here. Then we have a tertiary alcohol. Next thing we'll do is we'll look at how we name alcohols. And what we do is we select the longest carbon chain with the hydroxyl group bonded to it, and then name accordingly with the O as an ending, denoting the hydroxyl group. We keep the hydroxyl group so that it minimizes the number on the hydroxyl group. So let's have a look. Here, I have CH3, CH2OH, I have 2 carbons in my chain, so I have FN, and because there's no ambiguity with where the hydroxyl group is, I can just put ethanol here. There's a second example. If I'm going to name it systematically, I'm going to look at this carbon chain here. And I have 1, 2, 3 carbons, so it's propane. And then my hydroxide is in the 2 position. 2. Oh, let's look at this last one. Now let's look at the second example here. Here I have, look for the longest carbon chain including this hydroxide. So I start from here and then go down, down, down. So here I have 1, 2, 3, 4, 5. This is how I'll number my carbon atoms. So I have 5 carbon atoms, so that's propane. And then my hydroxyl group is in the 2 position, so it's propan 2-ol. Now let's look at my substituent. I've got 2 methyl groups, 1 on 2 and 1 on 3. So it's 2,3-dimethyl. So it's 2,3-dimethyl propan 2-ol. Let's look at these 2 examples. Okay, I have 2,3-dimethyl pentan 1-ol. Now I'll draw a 5-member chain first. 2, 3, 4, 5. I have 1, 2, 3, 4, 5. 5 carbon atoms. In the 1 position, I'll have my alcohol. So that's my OH going here. So there's my 1. And I have methyl groups at the 2 and 3 positions. So 1. And so this is the 2 and this is the 3 position. So this is the bond line structure here. If I have propan 1,3-diol, I have a propan chain. So that's 1, 2, 3. And then I look at the alcohols. I have 1 in the 1 position and 1 in the 3 position. So in the 1 position, OH. In the 3 position, I have an OH group. Thank you.